one. For two geometric sequences, a sub n and b sub n, the first term of each sequence equals each other. The fifth term of the first sequence is 16 times the fifth term of the second sequence. We're going to find the minimum value of a positive integer n such that a sub n divided by b sub n is greater than 10 to the power of 6. And this part here is just giving us information for when we simplify. All right, so basically let's let, since we have these two sequences, let's let a sub n divided by b sub n equals c sub n. Then that means c sub n is also a geometric sequence. All right, I'll just do that. All right, now let's let R be the common ratio for this. C sub n. I'm saying sub. All right, so then we're going to have C sub 1, and that would just be A sub 1 divided by B sub 1. Well, since they equal each other, that's just like saying A sub 1 divided by A sub 1, or B sub 1 divided by B sub 1, and that equals 1. Now let's look at C sub 5. That's going to be A sub 5 divided by B sub 5. Well, your fifth term here is really 16 times B sub 5, and then you're dividing by B sub 5. Well, this equals 16. And remember, for C sub 5, this really equals A times R to the power of 4, using this formula, right? So basically, this is going to equal, my A is 1, so this is going to be 1 times R to the power of 4, which is, if you power this up by, let's see, 1/4, that means R is going to equal 2. Now that we have our common ratio and our first term, we can write our formula C sub n equals 1 times 2 to the power of n minus 1, again using this formula. So now we know that A sub n divided by B sub n is greater than 10 to the power of 6. So that means, let's see, C sub n is greater than 10 to the power of 6, which means 2 to the power of n minus 1 is greater than 10 to the power of 6. Now we need to solve for n, so that's what we're looking for, n. So let's do that, and I'll write this again. We have 2 to the power of n minus 1 is greater than 10 to the power of 6. So what I'm going to do is take logs of both sides, get this n out of the exponent. All right, using your power property, let's move this power down. So we're going to get n minus 1 times log of 2 is greater than 6 times log of 10. Now, since there's no base written here, this is log base 10 of 10, and this equals 1. So basically what we have is n minus 1 times log of 2 is greater than 6. This is where this comes in, so we can substitute this in. I'm going to write this as n minus 1 is greater than 6. I'm just dividing by log of 2. But log of 2 is this number here, so I'm just going to write this as 0.3010. All right, that means we have n is greater than 6 divided by 0.0301, 0, and we have to add 1. All right, when you get that, you're going to get n is great. This is going to equal 19.93 plus 1. This equals 20.93. 0.93. Now, we need a positive integer. So the minimum positive integer. So we have to round this up. So the minimum value of the positive integer is 21. Thank you. Have a nice day. Bye-bye.